We're going to talk, the beginning of chapter 7 talks about matrices. So we have to understand what a matrix is and all the parts of a matrix and all the sort of words that go along with a matrix. So a matrix is nothing more than, like, the actual definition is a rectangular array of numbers, okay? So rectangular means like it's in a certain shape and it fits inside this rectangular box here. You draw the left and the right hand side of this box. And inside are these numbers, okay? And this is a generic form of what they look like, all right? So I'm going to give you these little numbers here and tell you what these mean in just a second. 1, 3, dot, 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 A, 1, N. Okay, so a matrix has what's known as rows and columns, all right? So this, as you guys know, rows go left and right. So this is row number 1 right here, all right? That's row number 1. And row number 1 has some, the things that we call inside here. So this piece right here, you know, this piece over here, this piece over here, all of these are called entries. Okay? So these are called entries. These are the row entries for row number 1. Okay? And we can have as many rows as we want. And this will be row number 2. And this will be row number 3. And so on all the way down. And this will be row something. I'll tell you in just a second. And then the other thing that a matrix has are columns, okay? And I'll just put C. This is column 1. This is column 2. This is column number 3, all the way out to column number N, all right? So there's these little subscript for each of these entries, right? See how it says 1, 1 right there? That stands for entry row 1, column 1, right? This is row 1, column 1. This is entry row 1, column 2. This is entry row 1, column 3. So this is entry row 1, column N. Very good. Okay. Now, if I actually finish up my columns here, all right, this would be A, row 2, column 1, right? This will be A, row 3, column 1. All the way down, this will be A, M, comma, 1. So that is row what? What row must that be? Yeah, this must be the mth row, all right? So I have these things called entries inside here, right? All right, so I have columns and we have rows. And then we have these entries that sort of fall along this main diagonal pattern here, okay? So this one would be A, 2, 2. Second row, second column. This would be A, 3, 3. Third row, third column, right? So if I kept going all the way down, what would this entry be way over here? A, M, comma, N. So notice this one kind of gives away. We use that one to determine what's called the order of a matrix. So the order of a matrix is the number of rows, comma, columns, okay? Rows, comma, columns. So in this case, the order of this matrix is an M by N matrix, and that's how we say it. So a couple of keywords that we want to remember are entries and order of the matrix. Entries and order. So the order is the number of rows by the number of columns. So this is an M by N matrix. All right? Now these right here, these entries, this entry here, this entry here, this entry here, this entry here, all the entries along this side, these have a special name, right? Those entries are called entries along the main diagonal. So as long as your, this is called the main diagonal. All right? And as long as you have what's known as a square matrix, you'll have that main diagonal there on those entries. So what do I mean by a square matrix? What do you think that means, a square matrix? Yeah, Megan.
That the rows and columns are the same.
Rows and columns are the same. So if we have this, so if we know that M is equal to N, if rows equal columns, then we know, we can say that we have what's called a square matrix. All right, square matrix. So that's another term that we got to get down.
And like the length and the width are the same.
Yeah, length and width are the same. You can think of it like that, right? So we have a lot of key terms here. Let me shrink it down so you can see an overview, all right? So a matrix is nothing more than a bunch of numbers inside a rectangular pattern. Those numbers are called entries. The subscript of those numbers tell us what entry it's in, like row what, column what. The name of a matrix is denoted by the order of the matrix, which means row by column, and we always say row by column. Rows go left and right, columns go up and down. If we have a square matrix, then we have main diagonal entries, and that's basically all the parts to a matrix. That sound pretty good so far? You guys on board so far? Easy enough? All right, good. Okay, so we're going to determine the order of these matrices here. So let me give you this matrix here, okay? Here is my matrix. It is a very tiny matrix, okay? So what would the order of this matrix be? Yep, this is a 1 by 1. I guess it's also square technically, right? Okay. And it's squared because m and n are equal if we use that definition. All right, let me give you another one here. How about this? 1, 5, 0. What is the order of this matrix? Here's an example of a matrix, right? It's a rectangular array of numbers. What would the order be? Remember, it's rows by column. So this is a 1 by 3. This is row 1, right? This is column 1, column 2, column 3. So it is a 1 by 3 matrix, okay? What is the entry in A12? 5, very good. What's the entry in A11? 1. What's the entry in A12? That's a 5, right? What's the entry in A13? 0, very good. All right, that's a 1 by 3 matrix, okay? Let me give you this one here. What about this? How about 0, 1, 5, 0? Okay? What's the order of this matrix? That's a 2 by 2, and it is called square, right? All right, very good. And what is the entry in? So this is what I like to do. I go row 1, row 2, column 1, column 2. You can put them on the top or the bottom, doesn't matter, okay? So what is entry in A12?
1.
1, very good. How about A21? 5. How about A11?
0.
And how about A22? All right, is that making sense? So we just have a way of actually describing where these things are in the actual matrix. Very, very helpful. Okay, let me give you this one here. 2, 1, -3, 6, 5, and 1. All right? What's the order of this matrix? This is how, so I got row 1, row 2, row 3, column 1, column 2. So what's the order?
3 by 2.
This is a 3 by 2. 3 by 2. Remember, it always goes row, and then it goes column. So this is a 3 by 2 order matrix. Order, right? All right, what entry is in A22?
6.
Okay. How would you describe entry number 5?
3, 1.
3, 1. Right, A31. All right, how would you describe? Yeah, entry 5.
Oh.
How would you describe entry 2?
1.
A11. How would you describe entry 6?
Well, you could say A.
A is for these guys up here, like A sub 1, 1, A sub, that's the A up there. Okay? Does that make sense? You cool with that?
Yeah.
All right, so while you're copying that down, what is this thing called? What are we looking at? There's a name for it. What is it called? Yes, very good. This is called a system. And this is a system of linear equations, right? Okay, and this was all about chapter 6. So this right here, that's a system of linear equations, okay? So from a system of linear equations, it almost looks like a matrix, doesn't it? I mean, what if I just did this, right, and I did this, and I kind of, took these away, took those out, right? Wouldn't I have a matrix? Okay, so that's what we're going to do, right? So from a system of linear equations, we're going to go ahead and write out what's known as an augmented matrix. Augmented, an augmented matrix. The augmented matrix is the representation of the system of linear equations without the coefficients, okay? So we're still going to have row 1, row 2, and row 3. Then we'll have column 1, column 2, column 3, and in this case,
Wait, is it representation
column 4,
without what?
without the variables
Oh, okay.
or the equal sign. So what's the coefficient for row 1, column 1? It had just an x, right? So that'd just be a 1. If I go across that row, I'd have 1, a -5, a 3, and it's customary to draw a line and then 11.
Isn't the line necessary though?
Yes, it is.
Is that what you learned? It's necessary or that isn't?
It's customary, yeah, we put that line there. Okay? What that does is that separates the coefficients, the variables, from the answers. So sometimes you'll hear me refer to this column as the answer column, the solution column.
But I felt like you got rid of the equal sign.
Yeah, the equal sign's not there, it's just a line. Yeah, yeah. It's all set up,
The
right?
representation of the equal sign.
You got it, yeah, yeah. All right, so finishing off this augmented matrix, I'd have a -1, a 2, a 1, and a 1, a 2, a 0, right? There is no y term in the third row. Second column, -5, and a 9. So that right there is called an augmented matrix. So one of the skills that we have to do is be able to go from a system of linear equations to an augmented matrix. Pretty basic, right? And what was the order be of this augmented matrix?
3 by 4.
This would be a 3 by 4. Very good. Okay. There is another type of matrix that we're going to use from time to time, depending on the application. And the third one, or actually the second one really, is called the coefficient matrix.
Coefficient.
The coefficient matrix. These are the types of matrices. There's only two, augmented and coefficient. Okay. And the coefficient matrix is exactly what it says. It's the matrix of only the coefficients. So from that system, the matrix would be what? 1, -5, and 3. Notice it's going to be the exact same as the augmented matrix, except without the answer column.
Why isn't there?
Because this is just called the coefficient matrix.
Okay.
These are just the different types. And depending on what we're doing, we're going to use the augmented or the coefficient.
Okay.
Most of the time, we're going to use the augmented.
And how does the coefficient get you the answer?
All right. So finishing this off, I'd have -1, 2, and a 1, a 2, a 0, and a -5. All right? So these are the types, and this is where they come from. We start with a system of linear equations. We put it into an augmented matrix and or a coefficient matrix, depending on what we want to do with it. By the way, the order for this one would be 3 by 3. Very, very good. And it would be square. Awesome. All right, ladies and gentlemen, here you have a system of linear equations. And you'll notice that there are how many variables in this system?
4.
There are 4 variables, all right? So I would like you in your table groups to write this system as an augmented matrix. But be sure that you line up your X column first, your Y column, your Z column, and then finally your W column. Now, we're just going to all agree to do it that way for right now. Okay? X, Y, Z, W.
Oh, that's the order you wanted?
Yeah, X, Y, Z, W. Okay, so go ahead and write the augmented matrix. So is this what you guys got? Hopefully you got this for the augmented matrix, right?
Switch to -5 and the 0 in the third column.
Yeah, isn't it -5 and 0?
So
I'm not gonna.
in my notes, that was a Z, so that's why I have the 0 there. But you know what? I bet you guys did it right. Right? Okay. Hey, and what's the order of this matrix, regardless of what we ended up with? Yeah, this is a 4 by 5 order matrix. Yeah, very good. So, how many of you remember the 3 row operations for solving a system of equations? Yeah, Tommy, give me one of them.
You can multiply a row by a non-zero integer.
Good, that's our second one. You can multiply a row by a non-zero. Very good, awesome. What are the other ones? Yeah, Jack, give me another one.
You can change the order of any of the rows. Switch. So you can
Switch.
Yeah, you can switch. You can switch any 2 rows. I want to make sure that you guys understand that these are all row operations. These are not column operations. You're not allowed to do this to columns, only to rows. Yeah. And anyway.
And you can add 2 rows?
Yeah. You can add a multiple.
Oh yeah, that's, yeah.
You can add a multiple of a row to another row.
By the way, Mr. Tiorio,
Yeah.
Mr. You know mole day in science, like.
All right, here we go. This is the system that we've got. We've got x minus 2y plus 3z is 9. We've got negative x plus 3y plus nothing is negative 4. And we have a 2x minus 5y plus 5z is 17. Okay, we're going to solve the system using row operations. The first thing we have to do is take our system and put it into what's that called? An augmented matrix. Very good. Okay, so let's go ahead and put the system into an augmented matrix. We're going to have 1, negative 2, 3, line, 9. Negative 1, 3, 0, negative 4, 2, negative 5, 5, 17. So far, so good?
Yep.
All right, now, ladies and gentlemen, to remind you our goal for this, okay, we want to get ones where my highlighted yellows are. We want ones there, okay? And then we want zeros where my highlighted blues are, all right? We want zeros there. So we want ones along the main diagonal of the coefficient matrix, okay? And we want zeros below each of those ones, because that will allow us to then determine the value for x, y, and z. Remember, right? This is row 1, this is row 2, this is row 3, this is column 1, column 2, column 3, and that will give us our answers over there.
This is just like the same rules apply.
Same rules apply. Column 1 represents our x variable, column 2 our y, column 3 our z. Same. There's two things that I'm going to do for this one, right? I already have a 1 in my row 1, column 1 position. I want to get zeros below that, okay? So how could I get a 0 where that first blue is? Steven, what do you think?
Add the first column to the second.
Yeah, row 1 plus row 2. And notice that I'm writing
Same thing.
I'm writing it next to the line that I'm going to replace, right? I'm writing my row 1 plus row 2 right next to row 2. That's the one I'm going to replace. I can also do another move. What would it be? No, we can't subtract rows. Yeah. Negative 2 times row 1 plus a row 3. Yeah, exactly. Well, those are the two things that I'm going to do.
Danny, I get what you're saying. Like, it's hard to, like, once you've, like, set yourself to problems like that, it's, like, really hard, yeah.
All right, so do we change anything? Do we change row 1? You have a question?
Yeah.
So here we go. We're going to have 1, negative 2, 3, line 9. Do nothing to that one, right? This is going to become a 0 by design. Okay? When I add those together, negative 2 and a 3, how much is that? That's a 1. That's good news. 3 and 0, 3. That's good. 9 minus 4? 5. Good. Okay, now let's do negative 2 times row 1 plus row 3. Then I'm going to have a 0 there. Okay? And then I'm going to have negative 2 times negative 2 is 4. 4 minus 5 is?
Negative 1.
Negative 1. Very good.
That
Okay.
looks promising.
And that looks good. Negative 2 times 3, negative 6. Negative 6 and 5?
1.
Negative 1 again, right? Negative 18 and 17, how much is that?
Negative 1 again.
Negative 1 again. All right, looking good. Okay. So remember, the goal, we want ones here. We're looking pretty good there. And then we want to get zeros here.
So just add the second row to the third row.
We're looking pretty good, right? Very good. So Steven says, well, why don't we just do, how about row 2 plus row 3, and we'll change it right there. And I would totally agree. Yeah, question.
Can we also multiply the third row by -1?
We could, but that wouldn't get us a 0 there,
Oh, yeah.
right? We want a 0 there.
That's the Y.
Yeah, we want a 0 there. Okay. So let's add those together. So I'm doing nothing to the first row. 1, negative 2, 3, line 9, 0, 1, 3, 5, 0, 0, what was that 2?
2
and 4. All
Pretty
right,
much
we are looking good. Check this out.
divide by half.
We want ones here, and then we want to get, again, zeros here. So what am I going to do?
Multiply the third row.
There you go. I want to do 1/2 of row number 3.
What'd you say?
All right, so
Brother's watching.
Wait, why is he doing that?
giving us a half of row 3. I'm doing nothing to row 1. 1, negative 2, 3, 9. 0, 1, 3, 5. 0, 0. What's half of 2? 1. What's half of 4?
2.
Awesome. Okay, so now here's what we have, you guys.
1, 1, 1.
This tells me that z is equal to 2. Right? That's what that means.
Yeah.
That means that 0 x's plus 0y's plus 1z is a value of 2. So z is 2. Therefore, we're going to go back substitute and say y plus 3 times 2 is equal to 5. So y plus 6 is 5 now. So that means y is going to be what, guys?
-1.
Very good. And then finally, go back again and say that x minus 2 times a -1 plus a 3 times 2 has got to be what? 9. Very good. So that means x plus 2 plus 6 is 9. So x plus an 8 is a 9. So, of course, x is a 1. So, therefore, our answer to this system is going to be 1, -1, 2, and there's the whole problem start to finish.